Okay, question 4. On a sketch of an Argand diagram, shade the region whose points represent complex number z. Satisfying the inequality is the difference between z and another complex number 3 and I is going to be always less than 3. And modulus of z is always going to be greater than z minus 4i modulus. Okay, let's start off with this part. If you start off with that part, oh, this is the second part, sorry. Okay, so first part, for A, they're telling you z minus 3 minus I is always less than 3. So this is the same as before, but basically they've introduced a new sign which is less than or equal to 3. Basically the radius can be 3 or less than equals to 3. So what do you do? First thing you do is z, take minus common, 3 plus I is less than 3. What are the two complex numbers? This z, which is unknown, and this, which is known, which is 3 plus I. Plot 3 plus I. 3, 1. So this is the imaginary number that is known. What are they telling you? Z can be in any point on the Argand diagram where the radius that it makes with this point, or the distance from z to this point is always going to be 3 or less than 3. So you draw a circle with radius 3 where the origin is 3 and 1. So if you do that, you get this circle, and you have to shade. If let's say this part was not there, you would shade this entire circle. You would shade this entire circle because z can be in any point inside this circle. That is the point of this inequality. Great. If you understand that, we move on to part B. Part B, sorry, not part B. The second inequality. The second inequality is telling you that z mod, or the distance between origin and the z, is always going to be greater than or equal to the distance between z, which is any point inside this circle, and 4i. Which point is 4i? So basically the on y-axis is going to be 4 and x-axis 0. Okay, this is the 4i. So basically they're telling you that the distance between this point and in any point z has to be less than the point made with origin. So if you try to understand, so let's say this is z, this is z, this is z, and this is z. Where do you see that the distance between this point, which is this imaginary number, and z, to be smaller than the distance between z and origin? That point is basically along this line. Because see, if z lies on this line, or this line, it is always equal. The distance between this and this and this and this is always equal. But if you take a point above this, in that case you will see the difference, or the distance between this complex number and this z is less than this the distance between this and this. So it does satisfy this equation. So which part do you shade? This part. Because if z is in any point inside this shaded region, it's always going to have a distance with this complex number which is less than the distance between that z and the origin. So that is the theory part. Now how do you calculate this line or find this line? You use the equation. That is why I wrote this. So basically solve for this, where z is a complex number, you include the complex number x plus iy, taking z as x plus iy, and taking z as x plus iy on this side as well. You're taking the modulus. What are you doing next? Iy, you're making the real part one part, this is the real part, and the imaginary one another part. So you're next going to do what? Put a square on either side. Put a square on either side so that you find the distance between this and this. So if I try to explain that within, I missed a step most likely, which is why it might be a bit difficult to understand. Basically, this is a distance because there is a mod, and this is a distance as well since there is a mod. What does this mean? X plus iy, if I try to represent this is x, this is y. I is basically, let's say, if x is in terms of per centimeter, y is in terms of per I. That is, I mean, if you just want to understand this, you can think of it like this. So you don't include I in your equation when you're trying to calculate the distance, because x, let's say, is in terms of centimeter and y is in terms of I, in a sense. So basically, for this, if you're trying to find the distance, what are you doing? You're going to basically use Pythagoras theorem and say that x square plus y square is going to give me r square. So r, which is the distance, the modulus, is root over x square plus y square. That is exactly what I've done over here. I found out the distance for this part, which is x square plus y square root, and x square plus y minus 4, which is the entire part, which is the coefficient for I. So y minus 4 whole square, and above it is a root. Since there is a root on either side, you can cut that off and exactly say x square plus y square is greater than equal to x square plus y minus 4 whole square. So if you do that, and if you try to make y the subject, you're going to get y is greater than equals to 2. So which part do you shade? This is 2. So the part that you shade is going to be this part. Pretty simple. Great. That's it for 4. Alright, so question 5. On a sketch of an Argand diagram, shade the region whose points represent complex number z satisfying the inequalities. Modulus of this is less than 2. An argument of z is less than 3/4 of pi. Let's forget this part and start off with this part. So draw an Argand sketch, and this is your diagram. Okay, over here what do? You're basically going to so you can represent this as this, and this is going to be less than or equal to 2. Great. If you do that, now you know this defined point, which is a complex number. So if you try to plot that 1 2, oh no, it's on the negative axis, sorry, 1 2 over here, minus 2, positive 3 over here. So if you know that, now what do? They are telling you that the radius between, or the distance between this and this, is always going to be less than or equal to 2. So if that is the case, the circle will have a radius of 2. If that is the case, draw the circle. Great. So now you have the circle. Now they're telling you that z is in a position where the radius is less than 2. So z is anywhere over here. But they've also given you another condition. The argument of z is supposed to be less than 3/4 of a pi. So argument of z means the angle that z makes with origin. So the angle that the complex number z makes with origin. Z lies between this circle, inside this circle. So take any z, and it should make a angle which is equal to or less than 3/4 of a pi. What is 3/4 of a pi? 45 degrees. So in that case, draw a line that bisects this quadrant, meaning 45 degrees. Over here it is 45 or 3/4 of a pi. If that is the case, now z can be any value in this part of the circle. Why? Because take any point on this circle and drop a point. Take any point and draw a line to origin and see if the theta made is less than or equal to 3/4 of a pi. By the way, 3/4 of a pi, I said, I guess 45 degrees. Basically, I meant the base angle, the angle that is going to be made. Sorry, I wrote 3/4. Yeah, so the angle that is going to be made in this quadrant is 45 degrees, but this entire angle is 3/4 pi. So take any point in this circle which is shaded, and if you draw a line, you will see that the theta made with origin is always going to be either equal to 3/4 of a pi or less than 3/4 of a pi. So z can only lie in this part. If you take a point over here, what happens? The theta or the argument becomes greater than 3/4 of a pi. So that is not going to satisfy the equation, which is why only this part. Oh no. Yeah. So that is 5. Okay, so question 6. What do you do over here? They're asking you that u is a complex number that is defined by √2 minus a √2i divided by 1 plus 2i. So they're asking you in a that express u in terms of a, where it is in the form x plus iy, meaning they don't want the denominator, where the denominator will have a complex number. So what are you going to try and do? You're going to try and simplify, basically remove the complex number from the denominator. In doing if you want to do that, what you do, you multiply with the conjugate complex number in both numerator and denominator. How does it look like? Let's see. You multiply 1 minus 2i, which is the conjugate pair of 1 plus 2i, and now simplify. So now what do? You pair up the real parts and pair up the imaginary parts. So if you do that, √2 minus 2a √2 minus a √2i minus 2 √2i divided by 5. So if you do that, you separate these parts. Minus 2a √2 divided by 5. And minus, what is it? You can bring minus to the front and say a √2 plus 2 √2 imaginary by 5. So you can represent this by this as well, and I guess this is the form they wanted in. Yeah. So next you can move on to question B, which is telling you express u in the form of, it is now given that a is 3. Great. So express u in the form of r is equals to I theta, where r is greater than 0, theta lies between minus pi and positive pi, given the exact value of r and theta. Basically you have to take it to another form. All right. They have given a as what? 3. So plug that in. Okay, so this is the expression that we received. Now if this is a complex number, you know this is the x, this is the y. So if you know that, you can draw a diagram if you wanted. So this is root 2, this is root 2, and this is r, the magnitude. So you need to find out r, which is going to be r is 2. So in that case, now you find out theta. Tan theta is root 2 by root 2, giving you a value of tan inverse of 1 is most likely 45. Tan inverse of 45. Do they want in pi? Yeah, so 45, so pi by 4. Yep, pi by 4. Theta is pi by 4. So we can say, alright, so since theta is pi by 4, we know r, we know theta, so we can express it as that. So in this case, u is going to be r is what, 2e pi by 4 I. Sorry, I pi by 4. The same thing. Alright, so the answer is oh. There's something wrong with this. I forgot to draw the Argand diagram. Right, so this complex number is basically at this position. If the complex number is in this position, it's going to be making this, and the theta is going to be this. So if this is pi by 4, this value, sorry, negative pi by 4 or whatever, pi by 4, this entire theta is going to be pi minus pi by 4, which is pi by 3/4 of a pi. So if that is the case, since this is on the negative axis, negative y-axis, this is going to be negative 3/4 of a pi, which is why it's not going to be, the argument is not going to be, theta can be called as pi by 4, the base angle is pi by 4, but the argument is going to be negative 3/4 of a pi. Theta can be said pi by 4, and the argument is going to be arg of what? U. Arg of u is going to be minus 3/4 of pi. Great. So if that's the case, you've done B. Alright, for question C, using your answer to part B, find the two square roots of u, giving your answer in the form r e to the power I theta, where r is greater than 0, blah blah blah. So basically they're telling you that they want the square root of u. You know the value of u, which is 2e minus I 3/4 of pi. Great. So if they want the square root, you basically are putting a power of half. So if that's the case, 2e to the power minus minus half. Sorry, half. So if that's the case, root 2 times e will have a power of half. So due to the indices rule, if you remember, the powers are going to add up, sorry, multiply. Since let's say x to the power 2 times to the power of 3, so in this case x will have a power of 6, right? So you can say in this case e to the power minus I 3/8 of pi. This is one square root. Now what is the other value of u going to be? This is one of the square root. Now if you look at the Argand diagram, you've received a theta of 3/8 of a pi. So minus 3/8 of a pi is somewhere like, if I copy that Argand diagram, right, so 3/8 is going to be somewhere is going to be somewhere like this, right? So this is one value of theta, minus 3/8 of pi. The other value or the other expression can be, you can be represented by, positive 5/8 of pi. 5/8 of pi. Right, so in that case you're going to get root 2 times e minus I to the power 5/8 of pi. Basically, when you're doing the root, you're getting a positive value and you're getting a negative value. In this case, since we are trying to get two complex numbers, we are getting one on the negative axis, the other on the positive axis. That's why we are getting another, which is 5/8 of pi, right? So I mean, let's say if you try to use the concept of normal algebra, x is equals to 4, if you x squared is equals to 4, you get plus minus 2, right? So even in this case, when you're trying to root the value, you're getting two theta values. You're going to get two values of theta. Since this is not really going to change, therefore putting a minus in front of the r is not going to affect. Why? Because the magnitude, r is basically the magnitude, right? The displacement, sorry, the displacement x, y. This r is the displacement, the magnitude. The minus is not going to affect that. However, the theta is the variable, or the only part that can change or be affected by the minus sign. So what you're saying is, if one value of complex number, if one argument is minus 3/8 of a pi, the other is going to be on the opposite end, which is going to have a argument of 5/8 of a pi. Therefore, these are the two values of y. One is root 2 times e to the power minus I 3/8 of pi. The other is this. Great. So these are the two answers. Okay, so question 7. The complex number minus 1 plus root 7i is denoted by u. It is given that u is the root of the equation 2x cubed plus 3x squared plus 14x plus k is equals to 0. Where k is a real constant, find the value of k. Okay, so they've told you that u is one of the roots of this equation. So since this has a degree of 3, there's going to be 3 roots. There are going to be 3 roots, but they've already given you one of the root, which is a complex number, u. And you also know that complex numbers come in pairs. So in that case, there is going to be another conjugate complex number, which is going to be minus 1 minus root 7i, right? So now, the way to answer this question, one of the way could be by finding one of the factor, meaning that you know two roots, which is minus 1 plus root 7i and minus 1 minus root 7i. You can multiply both of these as factors and get a equation which is going to be another factor of this entire equation. So what do? We are going to let's say x minus 1 minus root 7i. This is one factor, right? The other factor is going to be x minus minus 1 plus root 7i, This is the other factor. Now after opening the brackets, this is what we get. And this entire thing, if you take out the brackets and simplify, you're going to get x squared plus 2x plus 8. This entire equation is actually a factor of this big equation. This is a quadratic factor of this equation. So what can you do? If you want to find out the value of k, which is a constant, one method would be by dividing this entire equation by one of the factor. In this case, we know the quadratic factor. So if you know the quadratic factor, you can divide this entire equation, and you know after dividing this entire equation, you're going to have a remainder 0. So you're going to get a quotient or another factor. This is one factor, this is another factor. This is a quadratic factor and this is a linear factor, right? So after you get this factor, you should be getting a value of 0 as the remainder, since they've told you that both of these are indeed the roots of the equation where the remainder is supposed to be 0. Great. So you can divide this entire equation by this factor, get a quotient, and you know that at the end the remainder should be 0. So from this you will get 8 as the value of k. So how did we do this? First of all, we have x squared plus 2x plus 8. So you can multiply 2x to get 2x cube. So 2x multiplied by 2x squared, 2x cube, 2x times 2x, 4x squared, 2x times 8 is 16x. You subtract and you get minus x squared minus 2x plus k. Drop down the value of k. Next, you can multiply with minus 1 to get minus x squared minus 2x and minus 8. Since all of these values are going to be cancelled out, you know this is the right quotient. So in that case, the value for k comes out to be minus 8. That is how you're getting k is equals to minus 8. Great. Now for B, what are they asking? Find the other two roots of the equation. Okay, what are the other two roots? We have already calculated this in a way, since we know this is one root, and this is supposed to be one factor. Sorry, this is one root, and minus 1 minus root 7i is another root, and this is another factor where x is going to be half. So you've gotten 1, 2, 3, all three of the roots. Great. So in that case, we can say minus 1 minus root 7i is one of the root. The other root is going to be x is equals to half. Great. Next up, we have on an Argand diagram, sketch the locus of points representing complex numbers z satisfying the equation z minus u is equals to 2. Z is unknown. You don't know what z is, but you do know what u is. What is u? U is this. This is u. So what is the defined or the known complex number? U. So the first job is to plot u. So u is going to be minus 1 plus root 7. Minus 1 plus root 7. You plot this at the center, and they've given you a condition that z minus u, that distance, will always be 2, meaning the radius is going to be 2. So in that case, you draw a circle with radius 2 and center minus 1 and root 7. After you've done that, you have answered question C. Great. So they just wanted the sketch, right? Yeah, so it's done. Next, you can go to question D, which is asking you determine the greatest value of argument of z for points on this locus, giving your answer in radians. So they want to know what is the least argument of z. So the first question to you guys is, where does z lie? Z will lie anywhere over here, anywhere on this circle, on that specific circle. Now why is it not going to be inside the circle? Because they've given you equals to 0. So z can only lie on the circumference of the circle, where the radius is always supposed to be 2, or the distance between this known complex number and the unknown complex z is always going to be 2. Since they've already told you that it's going to be always 2, you cannot consider z to be anywhere inside the circle. Okay, so in that case, we can say that the least value of z, or the argument of z, is going to be somewhere over here. And if you draw a tangent, you're going to get the least, oh no, they asked the greatest value. So you're going to get the greatest argument of z, where the maximum angle is made with the x-axis, right? Since they're asking for the greatest value of z, the point over here is going to give you the greatest argument of z. Okay, so what if they asked you what is the least argument of z possible? In that case, you would draw a line which is tangent to over here, right? And this is supposed to give you the least argument of z. Alright, they have not asked you that, so we're going to focus on the greatest argument of z. In that case, how do we calculate the greatest angle? How do you calculate that? So there are two steps. First, you draw a triangle as such, where this is 90 degrees. Now, what do you know about this triangle? Oh, by the way, you have to find out this theta from this triangle. Let's call this theta 1, right? So from this triangle, you know the radius is 2, and the distance CO, you can figure it out using the distance formula for coordinates. -1 root 7 is the coordinate for C, and the coordinate for the origin is 0, 0. So you can find out the distance OC, where the equation is supposed to look like x minus x1 whole square plus y minus y1 whole square. This is the distance formula. Great. So if you know that, you can find out CO, and you also can find out, or you already know, CT. So from that, you can use sine. Yeah, you can use sine to find out this theta 1. Next, we can find out this angle. So if we draw the diagram of the triangle over here, you know the radius, you know this side, you don't know theta, and you're going to find out with the sine function. Great. So sine theta is going to be opposite by hypotenuse. So 2 divided by root 8, it's going to give you a value of pi by 4. Great. If you know that, next you can move on to the next part, where you need to focus on this triangle, where 90 degrees is over here. So if I redraw that triangle over here, you know the distance between CB, since it is -1, the distance is 1. Okay, the distance between B and O is supposed to be root 7, since the coordinate, y coordinate of B is root 7. Great. So if you know that, you can use opposite by adjacent, meaning tan theta, to find out the value of theta 2. Great. Tan theta 2 is 1 by root 7. So you can find out theta as to be 0.361. So if you know that, you know this theta, this entire theta. If you add these, pi by 4 and 0.361, you will get which theta? This theta, this big angle, right? So you already know this part. This theta is supposed to be what? This theta is supposed to be pi by 2, 90 degrees. So what do you do to get this entire angle now? You add pi by 2 plus pi by 4 plus this small angle, and you will get the total argument of z at this point, right? So you will get a value of 2.72 if you round it up. All right, so that is question 7.